Hello friends, I am Rahul and you are watching Truth of Physics. Today I will discuss the line integral of a vector field. So basically in this video I will discuss the physical significance of this line integral with an example of electric field. So first we will understand what line integral is. So suppose we have a path, we have an arbitrary shaped path. Okay, this is suppose A point, the initial point of the path, and this is the final point B. Okay, now suppose in this region, in this plane of the board, there is a vector field. Okay, the vector field is directed in suppose in this direction, the vector field, and we are going to cut this path into infinite number of infinitesimal small elements. What is that? We are cutting this path into very small distances such that every distance, every small distance, here I am representing this small distance with this. Okay, yes, this may be very large to you, but for your understanding I am taking this length, this big length. Okay, but assume that this is very small, infinitesimally small length. So if we are if we have cut this line AB with in this manner, so each part, each small part behaves like small vector element, path element. Okay, that is we are denoting dl, this vector. Why it is vector? Why it is vector? Because it has magnitude, it is its magnitude, the length, it is magnitude, and it is always directed in one particular direction. Okay, here this vector is dl vector is directed in this way, in this direction. In here the vector is directed in this way, in this direction. Here it is directed here, dl. Okay, so in each point of the path the vector is the element has different directions. So this is a vector element dl. So suppose we are considering only one vector element. Suppose we are considering this vector element, very small vector element. Okay, so in this vector element, suppose here at this point the vector field which we have considered before has a direction in this way. Okay, and suppose the vector is f. Now as this path AB is cut into very small pieces and we have defined a vector field here, so the vector field may vary point to point. Okay, so the vector field may vary point to point. Suppose in this point the vector field is f1, the vector, and the angle between dl, this vector, the path vector, path element, and the vector field is theta. This angle is suppose theta here at this point. Suppose this point is r. Now f1 vector dot dl vector, this line integral, this dot product. Okay, so what will be this? The result will be a scalar. We know that dot product result is a scalar. So if we integrate this over this path, okay, over this path, that is the limit is from A to B, then what we will get? This expression means that this is f1 dot dl plus f2 dot dl plus f3 dot dl. What are these? f1, f2, f3, that is at different points, suppose here dl is here directed along these, and here the vector field is f2, Likewise, the vector field at different points are denoted as f1, f2, f3 and so on. All the products, all the dot products of the vector field and the path element dl, we are taking all the products of such kind and summing it. That is the integration, and this is called the line integral of this vector field, of the vector field f. Okay. Now what it signifies? So let us take a very simple example of electrostatics. Suppose we have a vector field and the vector field here is a electrostatic field. Then suppose a point charge is located at point P and the point charge is q0 suppose, and there is a vector field directed along, suppose this way. This is the vector field E. So this point charge q0 which is placed at point P, here it is q0 charge. This charge will definitely experience a force, and the force and the magnitude of the force is q0e. We all know this. So F equals to q0e. Now if this test charge q0 is placed or is displaced from this point to this point, very small distance, okay, under the action of this electric field, then what is the work done? Then the work done, as this is very small distance, suppose this distance is dl, so this is the displacement vector dl vector, this is the displacement vector, this is its length. So dw, the small work done in this case will be what? Will be f dot dl, q0 e dot dl, and this is equal to f dot dl. Okay. Now if this is point A and this is point B, and the test charge q0 is taken from point A to point B under the action of this electric field, so what will be the total work done? So total work done will be simply the integration of this expression, and the limit will be from A to B. That will be the answer. So from A to B, q0 will be out of this integral, q0 e dot dl, and this expression turns into w by q0 equals to integration A to B E vector dot dl vector. So what is this? What this expression tells us about? There is hidden the physical significance of this problem or of this simple case. Here this term integration A to B E dot dl is like this, that is the line integral of the vector field E, the electric field. So the line integral of the electrostatic field from point A to B gives us this. And what is this? The work done to take a unit positive charge from point A to point B, and this is the relation between the line integral and the work done in electrostatic field. So I think that you have understand the importance and the meaning and the physical significance also of the line integral, and I think that you have also understand the uses of line integral. So if you are really benefited, so like this video and share this video more and more to your friends. Previously, I have also made video on physical significance of divergence and physical significance of gradient. You can also watch that. The videos will be given, the link of the videos will be given in the description box, or you will get the videos also on the I button. From there you can also watch those videos. Very soon I will also make a video on physical significance of Carl. So stay tuned and subscribe this channel if you are new to this channel. So take care of yourself. Thank you for watching.